welcome back. Let's solve Leetcode problems. Maximum score from removing stones. Okay, and then the problem is we are playing a game with three piles of stones have the size A, B, and C. So each turn we need to choose two different non-empty piles. Okay, and then we take one stone from each and then add 1 point to our score. So the game stops when there are fewer than two non-empty piles. Okay, and we have three integers A, B, and C. We need to return the maximum score that we can get. Okay, so for example, we have A is 2, B is 4, and C is 6. So the output is 6 because okay, so I think for this problem I think it's quite a greedy algorithm because I think in each steps we will need to choose the the price has the maximum stones, and the price has the second largest maximum stones to get the stones from those two piles. Okay, so let's check whether it's correct or not. For example, we have 2, 4, and 6. Okay, so we will get the stones from the largest and the second largest piles. It means after the first step the stones of three piles will become 2, 3, and 5, right? Because 4 and 6 are two largest piles. Okay, and then we keep repeating this step until we have fewer than two non-empty piles. Okay, so we will choose 3 and 5, right? We have 2, 2, and 4. Okay, and then we will choose 2 and 4, right? 2, 1, and 3, and then next step we will choose 2 and 3, right? It is 1, 1, and 2. Okay, next that is 1 and 2, right? We have 1, 0, and 1, and the next step is 0, 0, and 0, and then now we can stop because there are fewer than two non-empty piles. Okay, and then let's check for how many scores that we get now. 1, 2, 3, 4, 5, and 6. So the answer is 6. Is it correct? Okay, yes, it's correct. Even we have some different steps if compared with the explanation, but that's okay as long as we have the correct answer. It doesn't matter the way that we choose. Okay, let's check for another example. Let's say we have 4, 4, and 6. Okay, we will choose the two largest piles, right? It means after the first step it will be 4, 3, and 5, and then next is 3, 3, and 4. Okay, next is 3, 2, and 3. Okay, next is 2 2 and 2. Next is 2 1 and 1, and then next is 1 uh, 0 and 1. Okay, and next is 0 0 and 0. Okay, so how many points? 1 2 3 4 5 6 7 8 8. Is that correct? Oh, it's wrong. Why? Let's check again. Okay, we have 4 4 6. 4 4 6. We have 4 3 and 5. We have 3 3 and 4. 3 3 and 4. Okay, so we have 3 2 and 3. We have 2 2 and 2. 2 1 and 1. 1 1 0 and 1, right? And then how many? 1 2 3 4 5 6 7. Oh, it's 7. We don't count the initial one. Okay, it is 7. Okay, so it's correct. Okay, so I think that our greedy algorithm is the correct one. Okay, so let's think about how can we implement it. Okay, well, as I say, in every step, right, we will select the largest and the second largest piles. Okay, so to do that, what we do is in each step we need to sort, right? We need to sort A, B, and C in ascending order or descending order. It means anyway we have to sort for A, B, and C in order to get the largest pie and the second largest pie. Okay, but the question is, do we really need to do that? No, right? Because we already have a data structure that can help us to do that. What is it? So it is the max heap, right? The max heap. So if we implement the max heap, it means the 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 first element in the heap always the is always the largest element, and then the next is always the second largest, right? We don't need to sort for A, B, and C in every step. Okay, and then we will put A, B, and C into the heap if it is larger than 0. But if it's 0, we don't put into the heap, and we will keep repeating these steps until we have less than 2 non-empty piles, and then after that we have the answer, right? So that's all for the idea. Okay, so let's code it. Okay, first of all, let's declare the answer, and then finally return the answer. Okay, so we will use the max heap, right? So let's declare the max heap. So in Java, the max heap that is the priority queue. Okay, queue of integer max heap is equal to new priority queue. Okay, so this is the definition of the min heap, because the default of the priority queue is the min heap. The element will be sorted automatically in the ascending order. But if we want to make it becomes a max heap, we will need to reverse them. Okay, so collection dot reverse order, right? Okay, and then we will put A, B, and C to the heap first. A of B max if offer C. Okay, and then we will check why max if dot size is greater than 1, right? What we do, we will point. Okay, so in largest, the largest is the max heap dot point, right? And we have the second largest is max heap dot point. Okay. um, okay, what we do, we will increase the answer first, right? And then we will check if largest minus 1 is greater than 0. Okay, so we will push we will push it again to the heap, right? Offer largest minus 1. Okay, and if second largest minus 1 greater than 0, so max heap dot offer second largest minus 1. Okay, okay, so and then okay, I think that's all for the implementation. Let's try. Okay, looks good, and let's submit. Okay, accept.